Welcome to Brain Vision.
Hello friends, as shown in the figure, a rod AV of mass 4 kg and length 720 millimeter, that is 0.72 meter, attached to the collar of negligible mass at A and to the flywheel at position B. Mass of the flywheel is 16 kg and its radius is given, radius of gyration is 180 mm. That is 0.18 meter, and the radius of the wheel is 240 millimeter, that is 0.24. In the given position and when point B is directly above C, angular velocity is same. We have to find the angular velocity. So we have to calculate omega for omega 1 is equal to omega 2. Omega 1 is angular velocity in position shown, and omega 2 when B point just below C. Moment of inertia of the rod AB about its center of mass 1 by 12 mass of AB into LAB square. Substituting the value, mass of rod AB is 4 kg, length is 0.72 meter. So we will get moment of inertia of the rod about its center of mass 0.1728 kg meter square. Moment of inertia of the flywheel mc into k square. Mass is 16 kg. Radius of gyration is 0.18. So its value will be 0.514, 0.5184 kg meter square. Now see the initial position. This is the wheel. C point. This is the position of P point. This is the A. Say this angle is beta. This is the velocity of A. This will be the velocity of center of mass V bar. This is the velocity of A, B. This is center of mass CG. So center of mass is H1 meter above the center of the wheel. So for position 1 as shown in figure, omega is equal to omega 1 in clockwise direction. Sine of beta is equal to 0.24 upon 0.72. So it will be 19.471 degree. Height of center of mass of the rod AB above the center of V, half of 0.72 cos of theta. So it would be 0.33941 meter. Hence, gravitational potential energy MAV into GH1 4 into 9.81 H1 already we have calculated. So this gravitational potential energy at this position is 13.3185 joule. Now we will analyze kinematics. Velocity of V point will be R into omega 1, that is 0.24 omega 1. Angular velocity of rod AB will be 0 and velocity of center of mass will be equal to velocity of V. So total kinetic energy at this position kinetic energy of translatory motion, kinetic energy of rotational motion, and kinetic energy of rotation of the wheel. Substituting the value, mass of rod AB is 4 kg. Its velocity is 0.24 times omega. Omega AB is 0. IC we have calculated 0.5184 omega 1 square. So this can be written as 0.3744 omega 1 square. Now we have to analyze the second position. Position 2, in which B point lies just above it. So this is your C point and B point lies here. This is B point. Its velocity will be in this direction. This is centroid G. Its value height will be H2 and this is A. H2 you will get height of center of mass above center of V, half length of AB plus R, that is 0.72 plus 0.24, so 0.6 meter. So gravitational potential energy at this position will be mass of AB into G plus into H2. Mass of AB is 4 kg. Acceleration due to gravity 9.81 into 0.6, it will be 23.544 joules. Now angular velocity of rod AB we have to find. The velocity of B point will be R into omega 2, that is 0.24 omega 2. Hence angular velocity of AB will be velocity of V upon 0.72, that is 0.24 omega 2 divided by 0.72. So it would be 0.333 omega 2. Now velocity of centroid of the rod. Velocity of P by 2, that is 0.12 omega 2. Now calculating the total kinetic energy of the system. Kinetic energy of the rod, translatory kinetic energy and potential kinetic energy. Rotational kinetic energy. And kinetic energy of the wheel. Substituting the value, mass of the rod AB is 4, velocity of center of mass 0.12 omega 2, moment of inertia of the rod is 0.1728, and angular velocity is 0.333 into omega 2 whole square. Moment of inertia of the flywheel 0.5184 into omega 2. So total kinetic energy you will get 0.297 omega 2 square. Now applying conservation of energy. For position 1 and 2, substituting the values all we have calculated, applying omega 1 is equal to omega 2. So we can write 0.3744 omega 1 square plus 13.3135 is equal to 0.2976 omega 2 square plus 23.544. It is given omega 1 is equal to omega 2 is equal to omega. Substituting the value, you will get omega to be 11.602 radian per second. Applying this condition in above equation and solving, you will get omega. That's all for it. Thanks for watching it.